Let's look at number 33, search in a rotated sorted array. We're given an array like sorted, yeah, and rotated at some pivot unknown. Like it might be something like 4, 5, 6, 7, 1, 0, 1, 2. Okay, so the bigger subarray is to the left. We're given a target to search. If found, return the index. If not, return -1. I can assume that there's no duplicates. Of course, we can just uh, iterate through all the numbers and find the target with O n. But uh, re we are to return the method of O log n. This is just a hint uh, of us doing the binary search, right? Yeah. Let's analyze the problem first. So actually, after rotation, there must be something the right side are moved to the left side. So there are two subarrays like S1, S2, maybe S1 plus SK and SK plus 1 SN, right? K might be 1 or N. With this, S1 is bigger than Sn. So now when we are search, when we do our to do the binary search, we choose the number in the middle, right? When I choose the middle, it might fall into this part and this right section. In different cases, there will be different handling, right? So we need to add more if conditions there. We will just do the check when we write the code there. At first, I need to say if if nums length equals 0, return -1. And now we're doing binary search. Let I equals 0. Let j equals nums.length. While I is smaller than j. No, even if I met j, there's a chance that it is yeah, it should be equal to. You can check the number against the target. So the middle, we need to get to the middle. Middle equals, if they are even, the total count is even, we get to the left side. So math floor plus j divided by 2. Now let's compare. If nums middle, if it's equal target, then we just return the middle. Yeah, it's done. If not, if nums middle is smaller than target, now there are cases like if it's forwarded to the left part, if it's smaller than target and the target is to the left, right? And the other case is bigger than it. So how can we say that it's for the middle one is falling to the left part? Yeah, the first, it must be bigger than this one, and it must be bigger than this one. Yeah. Actually, no. If it's bigger than the first one, then it's definitely gonna be the left side. Right. If uh, if nums middle is bigger than SI? No, it's bigger or, because it might be falling to this part. Oh, let's write it down. So if falling to this part, we can say that SI is smaller or equal to S middle, and and SI is bigger than SN, right? J is smaller than, is something like this. Or it falls to the right side. The right side, then the first S middle is smaller or equal to Sn, and it must be smaller than this, because if falling to the left side, it will be bigger than S1. So it must be smaller than S1, but Sn is smaller than S1, so it's J. Okay, there are two cases of like this. So let's just check if it's bigger than this, then it must be falling on the left side. And if it's falling on the left side, we can safely falling on left side. We can safely move J to the middle, right? Because a target is wait a minute. Let's say target is smaller than middle. Because it's to the left, it's smaller than middle, and if it's falling, the middle is in the left side, smaller than middle, and middle is to the left side. And now we can check if it's bigger than S1. If it's bigger than S1, then we can safely move, right? Move the J equals middle minus 1. If not, wait, it's this is the case, right? Yeah, and for the other cases, the middle to the right. Okay, now you say target is smaller than it, then it must be to the left part, also to the left part. Smaller than it. Yeah, so I equals middle plus 1. Now we do the same here, because target is bigger than it. If it's falling to the left part, it's like this. Bigger than it. And then I equals middle plus 1. If it's a smaller than it, if this one, it's falling to the right part. If it's bigger, then it should be, wait a minute. It might be to the right or to the left. We need to check again. There's something wrong here. Wait a minute. I mean, their target is smaller than the middle one. If the middle falls to the left part, if it's smaller, then it could be, it could be this, right? Yeah. We need to check if it's bigger than S1 or not, SI or not. So here it should be, if target is bigger or equal to SI, then we move J, because it's to the left, to the left side, to the left. If not, it's to the right. I equals middle plus 1. And here we need to check the same, right? Now target is bigger than the middle. If middle falls to the left, then it must be on the right side. Yeah. But if it's smaller, we need to check. But if it falls to the right and bigger than it, it might be to the right and or to the left. So we need to check again. If target is bigger than SJ, we should move J, right? Because it's come to the left. And then in all the other cases, we move I. And finally, I and J were met and get the middle one. Middle is the same. And the target and move, and they will finally cross each other and it will fail. And then finally, we return -1. Let's run the code. Runtime error. S is not defined. What is S? Nums, man. There's no S. Yeah, let's submit. Huh? Got mistakes about this. 3 and 1. IJ. You check 0 and 2. Oh, shit. It should be -1. God. My bad. Still there's mistake. We console log IJ. Okay, we check 0, 4. We better relog. Okay. The middle is 2. It's smaller than 2. It's smaller than 2. And 2 is not bigger than 5. So fall into this part. I equal, kind of like we made a mistake. If target is smaller than 2, okay. While middle is bigger than I, no, it's smaller. So we fall in here. It's seems like we had a problem. Middle, okay. Nums middle 2, nums I 5. If it's bigger than it, then it's the first case, which is falling to the left side. But no, it's falling to the right side. For the right side, because it's smaller than it, middle. So, God. We made a mistake here. It should be this case. Oh. I need to pay more attention about the real conditions. I need to address them by commands, I think. Yeah, okay, our solution is accepted. So that is not very difficult. We are hinted. we have the hint that we should use binary search. We just find out all the solution, find out all the possible cases, and complicate finish. Yeah, just write. Just think about all the conditions and make no mistakes about edge cases, about the ending of the boundaries. Yeah. So the time complexity, of course, every time we cut down about half of the number, so it's a log n. Space, we don't use any array something, we just use several variables, so it's going to be constant. Yeah, that's all for this. See you next time.